Interesting.
Yeah.
All right.
Yeah, okay, perfect. So are we kicking off right from the beginning, I presume? So we're having some technical difficulties here. Lovely, no worries. So let's kick it off from the beginning.
All right.
Always challenging. Yeah, let's go. So yeah, welcome to Cloud Native Live, where we dive deep into the code behind Cloud Native. I'm Annie Talvastro, and I'm CNCF ambassador, and I will be your host tonight. So every week we bring a new set of presenters to showcase how to work with cloud native technologies. They will build things, they will break things, and they will answer all of your questions. So you can join us every Wednesday to watch live. So this week we have Andy here with us to talk about how to right size Kubernetes with a live coding demo. So very excited for that. And as always, this is an official live stream of the CNCF, and as such, it is subject to the CNCF Code of Conduct. So please do not add anything to the chat or to the questions that might be in violation of that code of conduct. So basically, please be respectful of all of your fellow participants as well as presenters. So with that done, I'll hand it over to Andy to kick off our today's presentation and take number 2, I guess.
All right. Let's do this again. So I'm Andy. Thanks for having me back on the show. I'm the CTO of Fairwinds. We are a Kubernetes first company. We've been doing Kubernetes for 6 or 7 years at this point. We run clusters for our customers. We operate those. And then we also have a lot of software that we provide in the Kubernetes space for a lot of different things. So today I'm going to focus on setting your resource requests and limits. So we've always told our customers, hey, set your resource requests and limits. This is what makes the scheduler work. This is how we're able to auto scale properly. This is how we introduce stability into our clusters. And it's kind of the first thing everybody needs to do with all of their workloads. And all of our customers would come back to us and say, that sounds great. What do we set them to? And so I said, that's a great question. That's a very reasonable ask. What should we set them to? So we would go look at graphs and, dig through their workloads and say, here's what we think you should set these workloads to for your resource requests and limits. And it's, sort of a bespoke process, one-off thing. It's not really something we can do continuously. It's not something we can, re-up on frequently. And so we said, there's got to be a better way to do this. So I went looking around at the various software available at the time. This was probably 3 or 4 years ago at this point. And I really wanted to learn Go at the time. And I was like, all right, what can we do here? What can we write? And I found the Vertical Pod Autoscaler project. And the Vertical Pod Autoscaler, if you're not familiar with it, it introduces a CRD called a Vertical Pod Autoscaler. And you attach that to your workloads. And it can automatically resize them based on how much CPU and memory they're actually using. I said, that sounds kind of cool, but I don't really like the idea of automatically doing that. I'm a big fan of infrastructure as code. It doesn't work well if we're using HPAs with our horizontal pod autoscalers with CPU and memory or memory. And so, what else can we do here? And I looked at it and said, well, it's providing these recommendations. These are really great. Why don't we just operationalize the vertical pod autoscaler a little bit more? And so instead of having to create a vertical pod autoscaler object for every deployment in my cluster and manage that separately, we will just do that for you. So write a little controller that creates all these vertical pod autoscaler objects and take all those results from the vertical pod autoscalers and summarize them basically. How do we do that? So out of that came a project called Goldilocks, which is one of our open source projects, which is what I'm going to focus on today. So why don't we just go ahead and jump straight into the screen share here. Thank you. So this is what Goldilocks looks like just when you open it, but under the hood, there's a lot more going on here. So I'm going to start with sort of the setup here and talk about how you install Goldilocks, you get it working. So I have here a Kubernetes cluster. It's a kind cluster running on my main machine. This one's 1.23. Excuse me. And installed a couple of things in here. So the first thing that we have to do is make sure we have metrics available. So let's look in our metric server namespace. We have a metric server running. We can, top pods and see the current CPU and memory usage for all the pods in our cluster. So that's good because we can't really make recommendations on usage, have existing metrics in place. So the second thing that you have to install as a prerequisite for Goldilocks is the vertical pod autoscaler. So I have done this already, and let me find the command that I use. So I just installed the VPA Helm chart from the Fairwinds stable repository. So we have a vertical pod autoscaler controller and the recommender. So if we look in the VPA namespace, we have a recommender. This is the only component of the vertical pod autoscaler that's required. And then the thing is the CRD for the vertical pod autoscaler and the vertical pod autoscaler checkpoints has to be on as well. So we're kubectl get VPA, and that doesn't yell at us that it doesn't exist. So we have the vertical pod autoscaler installed. And then the next thing that we'll do is install Goldilocks. So that can be done also via Helm, a fairly straightforward command, that Helm upgrade dash install or a Helm install. I've already installed it, so I'm using the upgrade dash install. In the Goldilocks namespace, I'm going to create the namespace, and then I'm going to set a flag called on by default. So this is a flag on the controller. Typically, Goldilocks works via annotating or labeling namespaces to enable them for Goldilocks. So if you want to just test it out in one or two, you can just run it in the default way and then label a namespace. The other way to do this is to set this on by default flag. And what this is going to do is tell Goldilocks, look at all the namespaces everywhere, all the time, no exceptions. So Goldilocks is now installed. So if look in the Goldilocks name, two components. We have a dashboard and a controller. First, we're going to focus on the controller. So let's take a look real quick at the logs on that controller.
And there's an audience comment, perhaps, maybe not a question quite, but comment that we can kind of, if you have any thoughts. So Vicky says VPA recommendations for memory requests/limits are risky.
I totally agree. So that is a great way to talk about what Goldilocks is for and what Goldilocks is not for. So Goldilocks is intended to give folks a starting point. You know, when you're spinning up services in Kubernetes and you have no how much resources you need to allocate to your different things, if you're not testing them locally to see how many resources your pod consumes, or you just need some place to start, Goldilocks is great for this. It's a great way to just see, hey, I'm roughly using this amount of memory and CPU. It's a great starting point for that. Is it 100% accurate? Is it the absolute truth of things too? Absolutely not. And I don't think you should just automatically copy recommendations from Goldilocks necessarily, but it is a great way to get started. But always definitely review over time, and always double check and do a sanity check to make sure that you're setting things reasonably. So great comment. Totally agree with you. The other thing you can do is connect the VPA to Prometheus to use a longer history of metrics to generate the recommendations, which does make them a little bit more accurate. So great comment. And keep those coming.
Yeah, and then there was a question regarding the logistics here. So Mauricia missed the first minutes. Will this be recorded so they can revisit? Yes, it is being recorded, and you can access it and see the recording in the CNCF YouTube channel just really quickly after this. So if you missed a few minutes, no worries. You can always watch it later.
All right. So coming back to our controller here, see that Goldilocks has run a few what we call reconciliations here. And so it has gone and created vertical pod autoscaler objects for all deployments in my cluster. This also works for other pod control stateful sets. It will work for, technically it'll work for jobs and cron jobs if you enable the RBAC, but I've had great results with the vertical pod autoscaler and jobs and cron jobs, something we need to look into a little bit further, but we're not going to talk about that today. We have a vertical pod autoscaler, and we see that it's generating records for all of our workloads in this cluster. And you'll see here that VPA is in mode off, which means it's not going to automatically update anything. It's not going to change anything in my cluster. It's just going to sit here and generate, which is exactly what I want from it. So I'm going to focus on the stress namespace for the moment because there's actually load here. I'm running a stress container. It's attempting to consume entire CPU, and I've set the CPU limit to 500 millicores. So it is being throttled very heavily right now, I would assume. And so we can take a look at that VPA. All the VPAs created by Goldilocks will be prefixed with Goldilocks, so that if you have existing VPAs, play nicely with those and not interfere with them. And we take a look here and we see that the VPA object has a status and it has this recommendation object in it. So this is the thing that Goldilocks is looking for. It's going to query all of these. It's going to pull these values. It's also going to take a look at the existing resource requests and limits for the pod. So there's pod, and we take a look at the resources block here. If we can find it. What did I do wrong? I thought I set resource requests and limits on this. Yeah, I didn't. There it is. All right, so we've got a limit of 500 millicores, and by default, because I only set a limit, we get a request of 500 millicores. So now we can take the dashboard. So this is where I'm going to start moving a little bit towards the live coding that we're going to do today, because I have the Goldilocks repo open here, and I have a branch open for the live stream. And I'm going to go ahead and build this and run the dashboard locally. So you can run, as long as you have a kube config that has access to the cluster, you can run the dashboard and the controller locally and just point at your cluster. I'm running the controller in the cluster just because I'm not going to mess with the controller code today. So I'm just going to let it handle that and not have to sit here running it into the background. So let's go ahead and run this, and we're going to run the dashboard command, and we're going to say on by default. This has the same behavior as on the controller. It ignores any sort of labeling or anything like that and just turns on Goldilocks for all of the namespaces. So we start that up and we see it's running on port 8080. So we'll go back over here to our browser and give it a little refresh, and we'll see that we're running the dashboard locally. So that's great. I can make changes and hopefully they'll show up here. So if we go take a look at our stress namespace, we're going to see here we have a single deployment in this namespace with a single container, and we're going to see two different sets of recommendations. And we'll talk a little bit about where these come from. Right now we're seeing I don't have an explicitly set CPU request. It has been implicitly set by Kubernetes, but it's not been explicitly set in deployment. And so I should probably do that. And then it's going to surface up the VPA recommendation here. So here we're saying this is if we want to use guaranteed QoS, which means setting our resource requests equal to our resource limits. There's some definitions down here. Then we're going to want to set our CPU request to 587 millicores according to the VPA, and our CPU limit to 587 millicores, and our memory request limits to 105 M. And so that recommendation from the VPA, and we have some YAML here if you want to just copy paste that in. And then over here we have the burstable QoS, and this is going to be the topic of the day, because if we go take a look, well, let's talk about this a little bit. So that's going to take the VPA lower. Let's go look at our VPA object again. This is where it gets a little bit confusing. So we take a look here. We have 4 different values that the VPA gives us. It gives us a lower bound, a target, an uncapped target, and an upper bound. So Goldilocks, for the recommendations guaranteed QoS, it's going to pull this target for both values, for both the request and the limit. But then for the burstable, where we're setting our requests lower than our limits, we're allowing the container to burst up from its requests, it's going to pull, and I have to double check this in the code once we dive into it, but I believe it's going to pull the lower bound and the upper bound as those two values. And so the dashboard is going to say inside of that upper bound and lower bound. And so this is where we introduce a little bit of confusing behavior in Goldilocks. And this is a decision that I made randomly years ago and regret it. All do when we write code, I imagine. So if we go take a look at a different namespace, let's just take a look at Goldilocks itself. We're going to see this here where it says our CPU request, 25 millicores, is equal to the burstable recommendation of 15 millicores. Now, you may be listening going, 25 is not equal to 15, Andy. That makes no sense. And I agree with you. It doesn't make any sense. We have an open issue with quite a lot of discussion that that this is under. But really, the way it's intended to work is, hey, we're saying your request, your lower bound to 15 millicores, your upper bound to 253 millicores, you're currently set to 25. That's within the range. It's in between those two. Again, probably the most obvious behavior. So today what we're going to do is at how we display the lower bound and upper bound and how we tell you, where you should set it to. And I have a couple recommendations from some coworkers on this behavior as well. So if we don't have any questions, which I don't think we do, I will go ahead and start.
At the moment. Yeah, so let's go ahead.
All right, we will carry on. So I have over here the Goldilocks code base. And so let me close this and we'll just start with the tree here so I can kind of describe what's going on. So in here we have a package. We have package dashboard, which controls the dashboard. And so we have a Goldilocks router, which handles the dashboard. And then we have a bunch of templates that create the dashboard. Yes, I know Goldilocks is deprecated. We'll be moving eventually at some point, but haven't had the time. So we will take a look. I know for a fact that the container recommendation here, this blue box, is rendered by the container.go HTML. And so we'll take a look at our Go template and see, all right, so we've got, a bunch of variables being defined at the top here. We're pulling in the CPU request, CPU limit, memory request, and memory limit for that container. So this would be the existing values that you're set to. We've got the lower bound and upper bound for both memory and CPU. Those are those VPA recommendation values that we're going to pass in. And then we have the CPU target and the memory target, which is what we're going to use for the guaranteed QoS. And then some other random stuff that's not super important. So let's take a look at we've got current values for the guaranteed QoS class. Well, we want to go down to the burstable QoS class. And here is where we start to see the recommendations. So we've got if the burstable, that's cost. We're not going to worry about cost stuff today. Let's look at the recommendations. Current CPU request. CPU lower bound. Where pull in our icon? Let's do this. Settings. Let's find the ID of the equals sign here. HTML is not my strong suit, so I'm definitely reaching a little bit today. That's what we're looking for. Comp icon. There it is. Okay, so here's our icon. And we're calling a template function get status range. we're passing it the CPU request, the current CPU request, the lower bound and the upper bound. So this get status range is, I assume, the function that we're looking for. So let's go back to our router and take a look, and we'll dive through the dashboard namespace function. So we're here, and this is what serves up the dashboard. I'm remembering now. In templates here, we have a set of template functions somewhere. Where did those go? Where are they? Well, we'll keep digging. Cost stuff we're not paying attention to today. And then we render, we create the data, and then we write template. And where are our template functions? They're in here somewhere. All right, we're going to cheat. We need get status range. So let's look for get status range. It is in templates.go. And we're going to go, I'm just scrolled right past it. Here we go. Get status range is a template function that we're passing in to the templates, and it is in helpers get status range. Now we have found the source of our problems. So we're passing in an existing value, a low value, an upper value, and those are all resource quantities. So this is where things get a little bit fun. These are resource quantities from the Kubernetes. I believe it's in API machinery. So we have they'll compare with each other. Where they get fun is in displaying them, because they are not a normal number, because we can display them in different units and things like that, which is something else we need to tackle in this dashboard, because you may notice we typically specify in megabytes, and we're here getting, I believe that's megabytes back. So maybe a problem for another day. We'll see if we get to it. So we're going to take a look. If the existing is 0, it's not set. So we're going to return this font awesome icon called exclamation. And then we also have a concept of both text and icons, because we want to put in both a text version of it for anybody using a screener instead of a font awesome icon. And so we have two different ways that we return this. We're going to return an icon and a text. So that's if it's not set. All right, so we're going to do comparison lower, which is comparing the existing value to the lower, and we're going to compare the upper to the existing value. And so we have our two comparisons, and so these come back as integers. The comparison function is going to return -1 if it's less than the other one, and +1 if it's greater. And so if the upper value is less than or equal to 0, or if the upper comparison is lower and the lower comparison is greater, then we're going to return an equals. This is where our issue exists. If it's in that range, we're going to return an equals.
Yeah, we have a new audience comment again from Vitaly again. Amazing, thank you. So they say for VPA in non-prod environment to be useful, LTs should be run constantly. In prod environment, there will be a resistance from app teams to deploy/use it.
Yep, great point. So, there's saying here, I'm assuming LTs means load tests. I can't think of another thing that would stand for at the moment. So yes, if you're running this in your non-production environment, you need to be generating load to get accurate. It's looking at VPA is looking at existing utilization. So obviously your non-prod environment, unless you're running load tests, the numbers will be off. And then in prod, there will be resistance from app teams to deploy or use it. I would argue that Goldilocks is not a responsibility of app teams to be deploying and using. I think operators, cluster administrators can run Goldilocks in the cluster and provide the results back. And because we're using VPA in non-update mode and we're using it in off mode, it's perfectly safe to run across your entire cluster to provide these recommendations in production. So I would say Goldilocks should be run in production because it's perfectly safe to do and by cluster operators. So thank you for the comments. All right, so now we need to decide what to do with our comparison here. So we know that the existing value is less than the upper bound and it's greater than the lower bound, but that's way too of a range for us to be saying this is equal. So I think what we want to do is take a look at how different it is. How much bigger or small is it than the lower recommendations? So let's just start throwing together something here. Let's say, let's figure out percentage difference of the lower bound. And so we're going to say that, I never remember this actual formula. So we're going to have to, I signed up to do math live today. It's probably a terrible choice, but we'll see how it goes. So we have definitely the existing quantity, the lower quantity. Existing. Existing is, okay, the current one. So lower, upper. We need to be doing this for, so here we're presenting I need to look at this, the CPU request. So the CPU request, and then we're passing the lower and the upper bound into this function. This may be a messier thing than I thought. So we have no concept here in the get status trace function, although we're asking for the resource request or the resource limit to pass back to our template. And so we need to say lower, upper. So in this case, we don't necessarily want to remove the equal sign, frankly, or change this logic completely.
And now there's a question from Zakaria. How can we set the CPU limit for a pod to avoid CPU throttling?
That is a great question and a very large and meaty topic that I don't necessarily have the time to go into today. CPU throttling is a very common issue, a very contentious issue. There's also been several Linux kernel bugs that made it in the past, and so it's gotten a lot of noise. And it's complicated because, and it was actually a really great talk that somebody sent me from KubeCon, I believe the last KubeCon North America, that talks about why we have trouble communicating about CPU, because we're specifying in fractions of cores, and CPU is actually calculated in time. And so we're sort of doing this weird translation of quantities that makes reasoning about CPU requests and limits a little bit funky. And so essentially, to avoid CPU throttling, turn up the CPU limit or turn it off. There's a lot of advocates out there for saying don't set CPU limits. I haven't quite jumped over to that side at this point in time, but it is in some cases a valid way to do things. But generally, it's just increase your CPU limit. And actually, I intentionally set this demo up with this stress container being throttled to sort of show that the VPA will detect that you're at the high end of CPU usage, but I don't believe it actually takes into account CPU throttling. So if you are seeing a lot of CPU throttling, this is one of those cases where VPA may not be the best recommendation. And so go ahead and turn that CPU limit up if it's affecting your workloads. There's no harm in doing that in most cases, assuming you have the space to schedule that pod and all of those things. So definitely a big topic and something that we should all learn more about. I definitely need to do a little bit more research there. So cool. Let's go back here to our code. I think what we want to do is just...
There's another question comment as well, which is amazing, by the way. Thank you so much for everyone for engaging. So Vitaly asked, let's say for microservice VPA recommendations to change to CPU 2.4 to CPU 1.3, how can you assure app teams that there will be no performance degradation?
I can't. That's why we test. So I think testing these changes in staging is the right way to go. As you mentioned, the same person mentioned earlier, load testing and staging is a very valuable tool. And so if you're not doing that, then maybe turning down your CPU recommendations is, it's a highly critical workload and things like that. Then perhaps not changing that would be the right way to go. I always recommend, best judgment, and, everybody's workload is different. Everyone's workload has different requirements. And we have to take all of those things into consideration as operators when making these changes. So just a recommendation for a reason. It is not an absolute for sure. All right. So back to this. I think what we need to do is just remove this particular if statement and say instead, actually, maybe we just remove it. I'm curious. Yeah, let's give that a shot. Let's restart our process here. So I just removed the statement that says if it's in between the two, give us an equal sign, which I believe means we're never going to get an equal sign. So that concerns me a little bit. So let's take a look at the effect that this has had on our dashboard. Let's go take a look. What was that? Goldilocks. Yep. There's the problem. Now we never get an equal sign or anything at all, which is not quite right. So if we are in between, but we need a not equal. So this is get status range. What are we using? We must be using a different function for these. Let me make sure we generate an equal sign. So that was the controller. So let's edit the controller. So I'm going to edit the resource requests on the controller to match the current recommendation. And refresh this. No, we are getting an equal sign on the left on the guaranteed COS. So we haven't broken that. That's good. And so over here for get status range, let's just go ahead and say if it's greater, we return greater. If it's less than, less than. And let's say if comparison upper if we get this far, let's go ahead and just return equal. do we have a FA equals success? Here we go. FA exclamation error is what we've been using. All right. So now, if we get anything, we're just going to return a not. Oh, I'm going to restart. Maybe break it entirely. Oh, there we go. All right. Oh, now we need to check actual equality because now we're saying 15 is not equal to 15. So we need a, just do live coding exercise, always dangerous. All right, if comparison lower equals 0, we're going to turn equal. What does that need to look like? FA equals success. Not there. Oh. Need to write our Boolean operators correctly. And let's do I'll start with that. Yes, I want the process too. All right. See, now this is where we're running into that problem I was anticipating, which is we don't know whether we're looking for lower or upper. So we need in our status range, we need to know, are we looking for a types of reserved word? Let's see. Quantity type. So we need to know if we're looking for a resource request or a resource limit. Let's say resource type. All right, so we're going to ask for a resource type. And then in our, we're going to completely change the logic of this function. That's going to be exciting. All right, but for our equals, another switch on resource type. We'll do case if it's a request or if it's a limit. And if comparison, so if it's a request, we want to compare the lower, and if it's a limit, we want to look at the upper. All right, cool. So we've got that. Let's go back here. So now we're going to have to call this function differently. So we know this is for the request. So we will say request here and request here. And for the limit, so we're just going to pass whether it's a resource request limit into our function. And hopefully once Apple stops yelling at me, we get, error getting template data. All right, we broke it. Request not defined. I probably need to, you know what? Then now I know why we, all right. So some variables just to make escaping quotes and things better. It seems like an awful way to do it, but I'm just going to follow the pattern that we have in place. It's amazing when you revisit code that you wrote so many years ago, the number of changes and things you want to make. But don't have time here today, although it does look like I might make it today. We will see. Aggregating template data function limit not defined. Didn't I? Why does it think I'm calling another function? Get status range. Oh, we got to do this again. And we need to request, limit, get status range. We need to do it here as well. All right. I was trying to avoid having to add another parameter to that function, but such is the way it goes. All right. Now, hopefully, we'll see. It did work. All right. So now we're seeing if we're exactly equal to the lower, we get the lower. If we're exactly greater than exactly, if we're off, we get a not. Should probably be a not equal to. But that's great. So let's go ahead and commit that change because that was annoying enough as it was. Replace equals logic for first of all QoS to be more clear. So that's kind of the base of the issue. That fixes the beginning of it. But we have 15 minutes left, and we would really love to know if we were to say, like, because this recommendation is going to fluctuate as you generate load. If we go look at our stress container, I'm going to guess, well, okay, stress is pretty consistent, but this will probably fluctuate between 587, up and down a little bit. And so we don't necessarily want to always suggest, changing those small increments. And so I have two recommendations from coworkers, which I think are really good, to either round the recommendation or only say it's not equal if we're within 10% or something like that. And I think what we should first do is round the recommendation off. So let's go digging for where we might do that. Oh, we should fix our tests. Testing is boring. I'm not going to do that here today. I will fix it before I open the PR, but let's leave the live stream on features, and I can do all the testing work later. Testing is very important, though. I'm not saying that you shouldn't have tests. But I think what we're actually going to need to do is modify the summary. Summary package is what actually goes and gets all of the data from the VPAs. So if we run the summary commit here, we'll actually get a big old gnarly JSON object that has all the data that feeds that dashboard. So it's sort of the data, the API side of things that's getting that information. So let's see where we go collect all of our VPA objects. Do summarizer, get summary, where is our function where we're going to get the summary, aptly named function. We're going to filter by namespaces. We're going to look in a cache that we keep locally just to speed things up a little bit. And then we are get or create namespace summary. There we go. All right. So workloads summary. So the first thing we do is we get the actual settings from the workload. We don't need to worry about that part here. But now here we are. If the VPA status is nil, that's what we do with that. If the length is less than or equal to 0, blah, 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 get the excluded containers. Yes. I'm vaguely remembering this now. This is one big ugly loop. Looking for, you have to go through all of the containers in each pod and separate them out because you can have multiple containers in a single pod. So we have this big here. But we're not going to worry about that too much either because that's excluding here we can't pull the workload spec, upper bound, utils.format resource list. Wonderful. We already have a helper function in here that's formatting the recommendation, which means we can go modify the format function to do our rounding. All right, so, this might be a place where we can fix the type of recommendation that we're giving as well. Okay, we're not going to do that alone, but if, so this is just formatting memory. Is that if mem exists, max allowable string length is 5, if length of memory is greater than the max allowable length, and it is less than that. Oh, we are rounding. Round up to this quantity is provided scale, ensuring that the value is at least 1. False is returned if the rounding operation resulted in a loss of precision. But I don't actually care if I lose a little bit of precision. Resource.scale, so we're already rounding a little bit, quite what we want.
Yeah, and then there's an audience question as well from Tahir. So recommendations are based on historic metrics from Prometheus. So if Prometheus pod, let's say, is restarted, OM, do we then incorrect recommendation? In what ways can we instruct for recommendations?
Great question. So recommendations can be based on historical Prometheus metrics. So the VPA, and we're really, all of these questions about, quality of recommendations and what the recommendations are actually doing have nothing to do with Goldilocks. I just want to be clear here. Now, I'm not saying that, I'm not responsible for folks who are using Goldilocks, but if you do have deeper questions about how the vertical pod autoscaler functions, I definitely recommend going to that repository and maybe contacting that community. But you can hook up the vertical pod autoscaler to Prometheus so that it will take into account historical utilization. And I do believe it actually takes out of memory events specifically. So I have not dug through this code in a little while, and it has changed since then. But I do believe when it sees historical out of memory events, it will increase in the memory utilization. But I can't promise that. So I definitely recommend checking with the vertical pod autoscaler folks. So it's in the Kubernetes autoscaler repository under the vertical pod autoscaler folder is where all the code for this lives. And I've actually done a lot of updates that we're incorporating into Goldilocks here soon, within probably the next few months or so. So we may get some enhanced behavior from that, because I know there's been a decent amount of work done on this repository since our last update. But great questions. Keep them coming. Okay. I'm not certain this is where I want to round my recommendation. So let's go back to our summary package. And we're getting the upper bound right here. So this is a resource list. Right.
Yeah, another question immediately here, which is great. Can it be integrated with Thanos Gateway, which may be persisting Prometheus data for a longer period? Tahir continued.
I have no idea. Quite possibly, but I really don't know. So from the VPA's perspective, if we go back to that repository and we take a look at, we're in the recommender package, and we look at the flags here on the recommender package, all we can give it is a Prometheus address and a Prometheus job name, and then a history. So assuming you have a Prometheus endpoint available, that you can, and it will query for the amount of time that you have told it to. In theory, that should work, but I am not at all familiar with Thanos Gateway gateway and how it functions, so I can't answer that question directly. Okay. Well, we only have a few minutes left, so I'm not certain I'm going to have time to round the metrics, round the numbers, but I will be working on that. Keep an eye out for a PR on Goldilocks within the next few days to implement these changes, but hopefully clarify the very confusing behavior of the equal sign in previous versions of Goldilocks, telling you that large numbers are equal to small numbers, because I think we can all do that math very quickly. So do we have any more questions? We do not.
Not at the moment, but while we see if there is any questions, you can obviously maybe let us know if there's any learn more resources that we can check out after the session or anything like that.
Yes. So we do have documentation for Goldilocks. There's plenty of information in here about how it functions. There's a whole FAQ on how to use it. So if you want to use Goldilocks, check that out. That is at goldilocks.docs.fairwinds.com. If you want to take a look at any existing issues or anything like that, or file an issue, please go to GitHub. So we have github.com/fairwindsops/Goldilocks. Fairly easy to find. In our Fairwinds Ops repository, we have a whole lot of other open source projects. So please check those out. We have things around policy. We have things around checking for deprecated API versions via. We have Polaris is for policy. And then Nova for checking for out-of-date versions of things, because we all know keeping all the many things that we run in Kubernetes up to date is a nightmare. So lots of great open source resources from Fairwinds there. I think that's it for resources.
Great. And I think it's starting to get closer to final call if anyone has any questions, because we only have a few minutes left. But anything else that you wanted to finish us off with from your side? While if anyone's typing a question, they can submit it to.
Set your resource requests and limits, folks. It's kind of my thing. I talk about it all the time. I work with Goldilocks a lot, and so many problems can be mitigated by just setting them properly and reviewing them over time, and load testing in your non-production environments if possible. So highly recommend that.
Perfect. And I don't see any new questions as of now, so I think we can then start wrapping it up. It has been really great, and I loved all the questions from the audience as well. So
definitely.
Thank you everyone for joining the latest episode of Cloud Native Live. It was great to have a session about how to right-size Kubernetes today. And we also really loved all the interaction and questions from the audience, such as I mentioned before already. And we, as always, bring you the latest Cloud Native code every Wednesday. So in the coming weeks, we have more great sessions coming up, so tune in then as well. Thanks for joining us today, and see you next week.